Let's read a little bit more from this British Geological Survey in Ireland and North Ireland and so on how the detective work is done on the rocks, the mountains, the volcanic mountains, and how they contribute to weather and climate, and how we reconstruct from the past. The formation of some rocks may influence climate. For instance, thick sequence of coal locked up atmospheric carbon dioxide as they formed. As we said, as the plants evolved and exploded and did a lot of photosynthesis and drew down carbon dioxide from the atmosphere and reduced the greenhouse effect and cooled the earth into a snowball earth and so on, a lot of that plant material got buried and became coal, right? Thick sequences of coal locked up atmospheric carbon dioxide as they formed. This greenhouse gas is now being released as we burn fossil fuels such as coal and oil. As another example, ash-filled skies from large volcanic eruptions block the sun's rays and cause global warming. So volcanic eruptions from the past have had impacts, and at present they have impacts as well. And there is another kind of eruption like what we had over let's say the Deccan Plateau. You have these seeping lava that can go on for a long time, right? Those are processes that are not as violent as volcanoes, but you have in Hawaii, for example, or Iceland, many volcanic activities or tectonic activities that keep on spewing magma that flows, and people go to see them and so on and so forth, right? On the map, letters in each colored region refer to the age of the rocks as shown in the timeline. For instance, the rocks in areas marked J are Jurassic age, while PT represent the rocks of the Permian to Triassic age. I'm not going to pay so much attention to the location from where these rocks came, the corresponding age, but we'll focus on the main story. And you can see that it can get complicated because these rocks are mixed up. Some are old and some are not so old and so on, as rocks tectonic plates move around. But let's read a bit about volcanic eruptions, which we have already done. This is the process that magma keeps flowing around, and evidences are found buried somewhere. And evidence from the volcanic eruptions: basalt and rhyolite lava and ash. Fine-grained crystals indicate rapid cooling at the Earth's surface after the eruption happens. Examples include the Antrim Plateau as seen at the Giant's Causeway. So let's not worry about where that is, but you can go and read more carefully and download this PDF, which is very big. PDF is a file format that you may know about. If not, don't worry about it. So here are more parts of the UK and Ireland and North Ireland where all the evidences were pulled together by the British Geological Survey. We also have to worry about ancient mountains, right? Did I miss reading something here about volcanic rocks? So this process, I missed it. Liquid molten rock pours out at the surface as basalt lavas. Sticky rhyolite erupts in violent explosions. So you have two types of magma flowing out. One is coming out of the rocks pouring out basalt lava, whereas rhyolite is what is there in violent eruptions or explosions. Okay, so ancient mountains, the processes of forming and the evidences. Okay, evidence. So let's look at the process. So it's hard to read. Process of forming mountains. Ancient rocks of varied origin deformed and baked under high temperatures and producing high temperatures tend to produce during collision of Earth's tectonic plates, forming the rocks of the mountain ranges. What is in the Himalayas need not be the same as what is in the Colorado Rockies or the Andes Mountains and so on. The evidence schist and oh, genesis are formed by, sorry, gneiss. This file is very big and I tried my best to blow it up without deforming it, but still I didn't do a good job for myself to read it. So here is the process, here is the evidence, just like the volcanic. So evidence is in schists and gneisses that are formed by the metamorphism of existing rocks and are often deformed and folded with new materials such as granite, garnet. Growing examples such as garnet, growing examples include Louisian rocks of the northwest highlands of Scotland during the Archean. So they formed a long time ago. Obviously I'm mangling this a little bit, so please go and read the original file, for which I have given the link here, okay? Or you can just Google Climate Through Time British Geological Survey and you will get the file, which is very nicely done, but it is so dense that it is best done as an interactive map online. Here I'm trying to cut it out and read it, and you can see that sometimes I mangle it. So here is Planet Earth for Earth Sciences for Society program of the British Geological Survey in Ireland and North Ireland. So here again, process and evidence of igneous intrusions, the process intrusion of molten rock into Earth's crust from below, crystallizing slowly at depth, may produce geothermal area of geysers and hot springs at the surface. You know, there are many places in Iceland and in Japan and so on, Alaska, that are famous for hot springs and geysers that you can go and enjoy, where Earth's energy from interior is coming out as nice water with some sulfur and health benefits and so on. It smells very strong as well, and it is safe to go and enjoy them, and they will tell you what are the protocols you have to follow. So the evidence for these igneous intrusions: coarse-grained granite and gabbro are evidence that magma crystallized slowly beneath the Earth's surface. For example, the Cairngorm Mountains. You can go and see it. Donegal, South Connemara, Silurian and Devonian periods, and Dartmouth Carboniferous to Permian. Let's read one more before I stop mangling these. Tropical swamps, rivers and seas, and that's how the environment would look like, and this is what the evidence would be from the past. So the environment: tropical swamps, rivers and shallow seas. Sand and mud accumulate in layers, sometimes rich in plant remains, which means it's hydrocarbon biologic material which can compress and become peat and then coal and so on. So evidence is in sandstones, mudstones and coal. So sandstones can be just abiotic or not having any biological material, and mudstones. Beds rich in marine fossils alternate with beds containing land and freshwater species. Examples include South Wales in Midland Valley, so they come from Carboniferous, and Weald, which comes from Cretaceous period. So you know what it is. You are looking at the composition to say what the process is, and then you are using dating, geochemical methods to date, to say how old it is, from what period it came. It came from the Cretaceous, and it formed because of tropical swamps and rivers and seas getting mixed up during the tectonic processes and so on. Read two more here: Ice Ages, the environment and the evidence. You can see melted away ice age. So environment: very cold glacial periods with ice sheets and glaciers alternating with warmer interglacial periods. So we are now in an interglacial period because the glaciers are there, but they are not as large in volume as during the ice ages. So evidence comes from rock surfaces polished and grooved by the ice. We called it the glacial striations before. U-shaped valleys and corries eroded by glaciers, so they are called fjords and so on. Drumlins molded out of glacial debris. If you don't know what these are, don't worry about it. They are geologic terms. Eskers formed by meltwaters till sands and gravels cover most of Britain and Iceland. It's coming from the Quaternary, which is much more recent period during the Pleistocene. Older Tillites are only rarely preserved in bedrock. So we talked about glaciers grounding up things and leaving them all over the place, with the terminal moraine, the lateral moraine, the medial moraine, and so on and so forth. The warm seas from the past, the environment would look like that, and evidence would be left behind in this way. So the environment would be warm, shallow to deep seas, sand, mud, and calcareous cores accumulate and build up. Okay, and reefs build up, sorry. So evidence comes as sandstones, mudstones, and limestones, including chalk containing abundant fossils of warm water species. For example, Central Plain of Ireland, Peak District, and Pennines, coming from Carboniferous, and North and South Downs coming from the Cretaceous period. Okay, so let's leave this here and read the further things as in the next podcast, because I'm already shouting a little and missing many things, but that's because I did not do a good job of translating the file into text on the PowerPoint. But you can go and find it and read it very carefully if this is of interest to you. But we'll come back and read more carefully in the next podcast. Okay, kiddos?